Afternoon, folks. Thanks for joining us on this webinar for building better LLM apps. We are at 2 o'clock, which is in Sydney. That's where I am. Wherever you're joining from, say hello in the chat. But for now, we'll just wait for a few minutes or two. We'll just give it a minute or two to let a few more people join before we kick off. So we're right here. Thanks. Okay, we have quite a big group here, so thanks once again for joining us for this live session of building better LLM apps. We have our presenter, Ali, who will be taking us through the next 2 hours, and hopefully by the end of it, you will actually learn quite a bit. We have Shishu, who's also available here to answer questions. So what I ask is, if you have any questions, post it in the Q&A, and we'll try and answer them as we go. If we cannot, we'll actually have some time towards the end of the session to answer your questions. But what I'll do now is I'll hand over to Ali, and then he will introduce himself, and then we'd want to launch a quick poll before we kick off. Over to you, Ali.
Thanks, Chris. Everyone, thank you for joining our workshop today. And in this workshop, we are going to learn everything about Langfuse and how it helps AI engineers improve their agentic application or any other LLM applications, and potentially like ship with confidence, because that's very critical when you are building an LLM application. Because of its undeterministic nature, you really need to be confident that what you are putting out there is actually going to work the way you expect. And Langfuse happens to be world's most popular open source LLM observability and evals platform, and we are going to learn today. Today, I'm joined with Sishu, who's also an SA. So I happen to be an SA as well. So we're both working at ClickHouse, which has acquired Langfuse about 6 months ago. So what is Langfuse and how it started? Basically, the co-founders of Langfuse were part of Y Combinator in 2023, which is basically a startup incubator, and where they were building something with AI, and they wanted to monitor what they were building, and also try wanting to improve it. So basically they were looking for a unit testing platform for their application, and there was none out there. So they started actually building it, and the rest of the cohort of the Y Combinator batch started using that, and that basically turned into their main sort of product. And that's basically how the story unfolded. So why do we need LLM observability, and why can't we not do it with the existing tools, right? Now, application observability solves a slightly different problem, which is basically saying health of the application operation, where LLM observability adds a new dimension, health and quality of the application. The quality is, I will emphasize, because you really need to make sure what LLM is outputting is actually correct. For example, here we are seeing a support agent, which has a bunch of tools to help its users. One of the tool is retrieving the policy, and it ends up retrieving the stale policy and incorrectly answer some user's question. Now, here you're seeing you can actually, if you have an incorrect answer, user can flag that, and you can have that mechanism, or you have to have some other mechanism to evaluate whether this response was correct or not. And where as application observability, if we were to be observing this with application monitoring, it would look okay because it is a correct sort of status code 200. So it looks like it's a correct response. And the latency was fine. There was no exception in the code, but the actual response was correct because it picked the wrong policy. And that is exactly what you you use LLM observability to first monitor, understand, and then from there on, you actually improve that. And that is a problem that a lot of companies that are building agents today face. So almost everyone we talk to is building something agentic, and like a support copilot, an internal research tool, something with RAG, and almost all of them tell us the same story. The demo looked incredible, but it's been stuck, almost ready to be shipped for months. And rarely the model quality is an issue because nobody see what the thing is doing. Because what is happening in the background, the agent steps the agents are taking, it is that visibility that is lacking, which is making which normally makes the team not confident to put it into production, right? With traditional software, if it passes the test, uh, it normally behaves the same in the production. With the LLM apps, they don't work like that. So if you change a prompt or a model, or even if the model changes the version, the same input comes out differently. So the output changes. So when this gives sort of a bad answer, how do you find out what is happening? How do you know why? Was it the prompt? Was it the true tool call? So most teams sort of the honor answer for them is we look at the log and guess. They don't have like a complete discovery. So how do you find out today when an agent gives a strange answer? Or how are you testing your prompt or model changes before they actually go into production? And that's what actually is standing between your application in the dev environment or during that prototyping and the production. And this is uh, you know uh, we have published in our Langfuse Academy. So you see that langfuse.com/academy. We published a lot of material out there. So you can, if you want to know more about this problem and how do people solve that, you can definitely look into the academy. Now, this is how we see it is like a full framework now. This AI engineering loop that we call. Half of it is online, and which is basically saying when your applications are running, we collect the traces. What do you mean by traces? Traces are the interaction between different components of your LLM application or agentic application. What tools it calls, how many methods it calls, and how did it actually get to the full answer that it retrieved. Then you basically monitor that. You look for, operational and also qualitative metrics. So that's your monitoring. And this happens online. And then there are things that you do offline in your dev environment, which is essentially saying you will create a golden data set, or what we call normally data set in our terminology, which is either synthetic or from your users or SMEs provided input questions. So what are the possible questions your agent is going to receive? Or what are the possible scenarios your agent is going to face in the production? And then what is the expected output against those scenarios? So how do I measure if the agent is actually doing a correct job or responding to the question in a correct way? So that data set is the key thing that has the inputs and the expected outputs. Then you run these experiments through your CI/CD or offline environment where you take all of those items in that golden data set or your data set, you run them through the application logic or agent logic, your prompts, your models, and then you evaluate them that whether the output is close to the expected output. Remember, because we are dealing with LLM can say same thing in different ways. So you normally will not be comparing exactly the same things unless it's a very deterministic like output, which is like maybe uh, a structured response from an agent. But you generally will evaluate based on the similarity of the response. And those scores is what gives you a metric that whether your application or whether your agent is ready to go to production. A metric that could be around correctness, it could be around your relevance, or it could be around safety in certain situations. So these are the metrics that you normally capture, and also there will be a bunch of metrics that will be very specific to your application. For example, in here, where we saw an example where the policy was picked and it was wrong, so you may want to score whether the correct policy was picked. So you may want to have an evaluation of correct policy being retrieved. So that could be your metric. And across all the dataset example, have you does the agent consistently pick the correct policy? That could be the metric. So these metrics could, the evaluation or scores or of these metrics could be custom based on your application. And also there could be some common ones which generally industry practice. And from there, you deploy the production, you observe the traces, you monitor for the failure modes of your agents, and then you feed that information back into your data set. So you continuously improve that loop. And that's exactly what Langfuse offer as a product. It gives you tracing, so the ability to see what exactly is happening. It gives you monitoring, so you can actually capture those traces and evaluate them online. And then with this evaluation, you get the scores. And if your scores goes below your confidence threshold, you can potentially send an alert to your team, and then they can go and fix either the prompt or the model, whatever is actually degrading that quality. And then you take that information and bring that back into offline testing in your data sets and experiments. And then evaluation also runs together, either online and offline, offline on the data sets, online on the traces. That keeps an eye on how your applications are working. And there's also a critical feature called prompt management that makes you take those prompts which run those agents out of your code and put them in a repository in Langfuse, so that every single time you have to make a change to improve the quality of your agent by changing the prompt, you don't have to redeploy the whole application. All you do is you change the prompt, run experiments either online or run side by side in the UI, and see if the quality improves. You can change the label of the prompt to something like production, and then your application, without deploying, without having without having to re-go through the deployment process, it can just pull the latest prompt. Right. So this is what the observability and tracing capability looks like. You can see on the right that exactly is the flow of the agent, how many steps it took. It could be tool calls, it could be LLM calls. There could be many things that agent could be doing. Having captured all of that allows you to debug the failures, also and filter and search the interesting scenarios that you may want to understand, better your agent's behavior or your user's input better. Evaluation and human review is also part of the product. So as I said, evaluation could be online as LLM as a judge, or it could be run as online as your, custom code, or it could be run offline with your data sets and experiments. And Langfuse gives you a really strong capability into maintaining these eval scores and comparing them against each other. Like, for example, you run prompt changes across multiple experiments, and then you can see how individual experiments score against each other. Human review is also critical. So, for example, if your traces are looking like if you understood from your traces that users are consistently asking for things that you did not take into account at the development time, you can have them reviewed by human. So there is a feature called annotation queues, which allow you to pick the interesting traces and put them into these queues where SMEs can jump in and see the input and output of the input of the users, output of the agent, and potentially give you some additional information. Like, for example, after reviewing, they can tell you whether this is a scenario that your agent needs to handle better, or this is a scenario your agent needs to refuse cleanly. And we will see that in the workshop as well. So human in the review is a critical part of this process, and we offer annotation queue for that. Now, every LLM call has token input and token output. We track that with every call. Every call that is made to the LLM or the tools has latency response time. We capture that too. And of course, the quality is measured using your LLM as a judge. So you can also see those evals that are scored online. They can also be tracked and monitored. So Langfuse offers you dashboarding capability, so you can actually create your custom dashboards. It comes out of the box with the dashboard. It tracks your costs, so you can actually alert yourself if your token spend of your agentic application is going beyond a certain threshold you expected. So you can monitor all these metrics. Now, from prompt management perspective, you can manage the prompts, you can version the prompt. It's kind of like a Git for your prompts, and without having to change your application, you can version the prompt and improve the prompt, do side-by-side experiment with these prompt changes, all within that Langfuse UI. Now that is one of the reason, like those rich set of feature and all open source is one of the big reason why it is the most popular open source platform in this category. We have 32,000 GitHub stars. We have 21 of the Fortune 50 companies using it, and so over 80,000 community members. I think now it's close to 100,000 community members that actively interact or build on top of Langfuse. Now, as I said, there are a bunch of companies from Fortune 50 using Langfuse. There are a bunch of companies, there's some companies we are listing here. Canva, which is a very popular design application, which is based in Australia, and they use Langfuse heavily for handling user interactions for their AI support bot. Merck is a big shipping company. Merck is a company that actually is shipping AI with confidence with self-hosted platforms. So they actually manage Langfuse OSS and Enterprise. And we also have this other company called SumUp, which also have been able to reduce their cost with the help of Langfuse. And this is the quote from the Merck's CD AIO. And he thinks that generative AI will only earn enterprise trust when you can actually see what is happening under the hood. And Langfuse is the tracking of the Langfuse actually gives you the prompts, the response latencies, and the cost. That visibility is what he thinks that every company needs. Now, how does Langfuse charge? If you go to Langfuse Cloud, we have different tiers, and it's based on the scale and the usage. So you have free tier, which is really you can register for it and start using it, and it's pretty much sufficient for a small team or for a small prototyping project. It should be enough. But then we have other tiers like Core and Pro, and then the enterprise. The enterprise will give you the enterprise features like SOC 2, ISO 27001. We do also have a HIPAA compliant region as well. So Langfuse Cloud is available. And we also, because it's an open source software, we also offer enterprise in the Salesforce, which means if you connect with our sales team, we can offer you an enterprise key, which can be deployed within your self-hosted. So if you are today using in your own virtual servers or EKS deployments, you can deploy those enterprise features with the help of the key that we provide, and it turns on those features. And that means you can still work, you can be supported in that setting as well. So do contact our sales if you are interested in using in your companies. Now, let me just get quickly to today's workshop. So in this workshop, we will be creating an agentic application, which will be a dead IT, an IT support agent for a hypothetical dad, right? And what we will do is, what this application does, it allows, a dad to ask question about how he can do certain things in his phone, and then the agent is going to retrieve the knowledge from the repository that we have created, and then it answers those questions from there. The agent also figures out which type of phone it has. So we will see how that application goes from blindness, like in a sense that you would have, when we start, there will be no visibility. And then we start adding that visibility. We'll see how the whole agent works, what are the tools it calls. Then we externalize those prompts so that, prompts changes that we do not require a deployment of our application. Then we will set up some monitoring to catch some of the requests that, dad may ask, which may not be, in the scope of the application. For example, that can ask, how do I let's say, file my taxes? And that is something that is not supposed to be answered by the agent. So we'll capture out of scope questions, and then we will go through the data sets and evals. So that's what we will cover. And that's basically the 8 modules that we have. Now, I know that we might not have all the time to cover all of that, but so the way we are going to work is we're going to give you uh, at the repository for the workshop. You're going to download the repository in your laptops, and then we will have instruction within that repository. So it's basically self-service. You can download and run it at your own time. For the time period of this particular webinar, we're going to give you an OpenAI key, which you can use to make progress within this application. And then we'll see if we actually can get to the module 5 and 6, which is the data sets and experiments. I will be running this workshop on my laptop on the computer, on the screen, so you can follow along with me as well. So how do we start this lab? Now, because there are, there's a number of attendees here, so I am going to ask you to check if you have those prereqs already in your laptops. If not, I'll give you a moment to go to these websites in the top right, which actually is, we need the Git. So you should be able to pull the repository from GitHub that is needed. And also, in order to move between the labs, we do have some commands for checking out tags in Git repository, so you can actually continue to make progress. We will be building a TypeScript application, which means you need Node to be installed in your laptop. If you don't, and if you feel like you can just watch me doing it, you can do that too. So number one, we will want you to go to, within your laptop, go to langfuse.com/workshop, and I'll actually show you what that looks like. langfuse.com/workshop. And that is the page that we will be gathering the data during this webinar and after this webinar as well. So you can see, this is instruction for the learners. So what we need to do from here is, you will get the link for GitHub, our repository. So can I ask Sishu for you to share? Let me share that too in the chat window. So I have shared the repository. Cool. In the chat window, so you need to clone that. So let me just open a terminal window in front of you. and start doing that. All right, so first of all, we're going to clone this repo. So here, so I'm going to go to my development folder. I'm gonna make a directory called webinar Langfuse, webinar Langfuse, and then I say git clone, and the repository URL will be in the repo. So if I go back to my repo, copy this URL and clone it. So that's the first thing we need to do. And let me just take a quick poll or show of a hand in chat. Let me message you here on the chat window. Has everyone got Git? So give me a thumbs up or a thumbs down so I know where we are in terms of who can operate with GitHub. That's fine. You can be in Windows but you can still follow along. Like the commands would work the same. So if you have Windows, the git clone will work exactly the same. So you go to MS-DOS, whatever that prompt thing is in Windows. I forgot the command prompt, and you can clone your repo as well. Cool. Now once you have the repo, it will look something like this. So I have opened that in that IDE. So I want you to, once you clone that, open that in your IDE. Okay. We're going to go a bit slow here so everyone can catch up. And the first thing, so that's the first thing. Clone the repo. Okay. Then open that in IDE. And then you will have the env example file. Make a copy of that. So copy and paste again in this folder and rename it to .env. So that file is where we will put all our keys and information. And I'll show you that in a moment. So let me just ask, has everyone cloned the repo? All right. Right. So good. At least I need at least 10 thumbs up to move forward. We have a message in the chat window. Please give me a thumbs up on that so I can know like people are progressing. Nice. All right. So awesome. Now, and make a copy of that env file. Either you do it on the command prompt or you do it in the IDE, copy paste. Okay. Then you need the OpenAI key. So in that environment example, your key will look like that. Now you need to replace it with the key that we just gave you in the chat window. Copied give me a thumbs up. I have copied OpenAI key in env file. So just give me a thumbs up on that so I know like at least 10 people have done that. Awesome. Awesome. Thank you so much for that interaction. And the people who do not have Git or TypeScript or Node, and then they feel like it's going to be hard to keep up, they can definitely follow me along. So I'm gonna walk you through the whole workshop, or as much as we can in here. So now that is copied, but your env example will look something like that, right? Because you have got that OpenAI key, right? But you don't have these Langfuse bits in here, right? The secret key or the public key. So now I want everybody in this workshop, regardless you're going to do you're going to follow along or you're going to just watch me. Go to langfuse.com and click Launch App. When you do that, pick the EU region if you can, and then you will be, let me just sign out for a moment. you're going to land into this page. Click the sign up and sign up for an account, right? So I'm going to sign up for an account. When I do, okay, so my company works on ISSO, so I am going to just sign back in. So let me sign in, and I'm just going to say, Ali. So now I'm going to ask the question. I have signed up to langfuse.com slash sign up. What? Langfuse.com. Go to exact. So langfuse.com, cloud.langfuse.com. So I have signed up to cloud.langfuse.com. Give me a thumbs up on that, and then I'll actually proceed from here. Good. I need some more thumbs up so I can carry on. So once I get like now we'll wait for another 4 or 5 thumbs up before we do that. Awesome. I'm still waiting. I need the 10 thumbs up. Cool. Awesome. Awesome. Perfect. All right. So for the ones who are waiting for me to proceed, just give me a moment and we will be there. All right. So now when we are in there, you will already have some organization created. So you will have a prompt that pushes you to create or that asks you to create the organization and the project. So I'm going to create a project here, right? You will be seeing that you will be a hobby account. So I'm going to create a make sure you are EU region, right? Create a project. I'm gonna name it you can name it anything, your name or maybe I will just say my webinar project. Okay. And when I do that, Langfuse is going to prompt me to create new API key. Okay. So I'm gonna click the create new API key button, and then boom, you got that keys, you got that environment variables that you need for you to start working or putting that into .env file. Just use that option to copy into clipboard, go to your IDE and .env file, not the example file, .env file, you replace these three. So I'm going to replace that. And now my code is ready to be launched. Okay. So I'm going to go to my repository. I'm going to cheat a little bit. I'm going to go to my webinar, 3rd of July, to Langfuse. So this is where, I've got my clone repository. So here, in order to run this application, we're going to do, just a second, let me just get that instruction file. So I'm gonna, so once we have that, we go to learner. Make sure you are following the learner docs, okay? So in the project, we have a learner docs learner folder and setup.md. We need to be here. So I'm gonna paste this link. This is the place we start from. Okay, so I've pasted this link in there. It is the same repository link, but it's got the instruction. So we did the cloning already. Now we will check out a specific tag that will bring the code into a shape that we want to start with. So I'll just do this. And I am now at that tag. So I've done already copying my API key. So I'm assuming people have done the project API key deployment. So let me pause here and ask you, have you copied project keys in .env file? Give me a thumbs up. From there, we will start moving a little bit faster. All right. So this is looking good. Now, the first two commands we are going to run is basically we're going to install CLI for Langfuse. Uh, I haven't run this command in Windows, so if it doesn't work, then it's okay. I then we 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 need it for later modules. If you use Claude, you pick the code the code harness you use or the AI tool that you use. So there are a bunch of AI tools that you can install these skills in. If you have Claude, you can select Claude. If you have if you have uh, you know codecs, you can actually select that. If you have Kiro, you can select that. Uh, yeah, so whatever you have, you can actually use this to install skills. So it actually enables, if you are using AI, agentic sort of coding assistant, it will enable you to do that. It is not a project, does install, don't worry about it. We will just carry on and with our project. So that is just for you to get like those skills and the CLI installed locally for you to work with your agent of tooling later. All right, so now we are here. We have copied the env file. We got the all env all project keys in. I'm going to start running the app. So how do I run the app? I will run these commands. So in the setup.md, we do have these two commands, npm install. And I'm going to increase the size, npm install, and npm run dev, npm run dev. So that's basically what we will do. Now my application is up. So let me go to my browser and then say localhost. I think it's 3333. Boom. This is my app. Now I'm going to ask, is your app up and running? Give me a thumbs up. Okay. And is your application connected to OpenAI and answering the questions correctly? Like when you say, how do I turn on the Bluetooth? You get that. I'll pause here for Satyajit for you to catch up. So what did we do? We actually went and followed the setup.md. And here we have 4 steps that we've gone through, got the API key, we install the Langfuse skills. That's an optional step. We configured the env. So there was a copy. This is what I did first thing when I did IDE. We already got this in our env, and then we install and run. And that's what we got. Our application is running. Awesome. So just keep giving me thumbs up on my message so I get like a good count of people to proceed. And if you have message, if you are struggling, just send us a message and we will be fine. Public and secret key will not be the same. That's a good question. So when you go to Langfuse and you created that project, like the way I did this, I think this was my webinar project. So now you can go to, if you've already created the project and you were not able to copy the secret key and public key, you can go to settings, go to API keys, and then create new keys. I've already got that. So if you see, I've already got those keys in my env. If you couldn't copy, you can create a new one, and that's okay. So awesome moment is saying 401 incorrect key provided. So you may want to do the key. Okay. All right. So that's fine. We will make sure the OpenAI key that we pasted is correct. Okay. I'm going to paste it again. Can you try the key that I pasted? And how you are going to use that is, let me make sure that you've got that right. In, in the IDE, you have to paste it under the key called OpenAI. Make sure that you have that key in here. So your env should look like that. Okay, so I'm gonna wait for people to get their OpenAI key correct. How do you know your OpenAI key is pasted and is correct? Is your application, if it's running, then it should give you a proper response, like the way I did. I asked the question and it gave me an answer. Okay, so connection error. Please send me the secret incomplete. I'm still setting up environment. So Muhammad Yusuf, you need to create the project in Langfuse because I cannot give you my key. Otherwise, you will not see in your Langfuse application how it works. So go to did you register for langfuse.com, cloud.langfuse.com? You register, you sign in. When you sign in, you create a project. When you create the project, you come to the project setting, which is over here. So you come here, you have the project. In the project, you will have the setting. So if you see the left side, there's a setting. You click the setting, you go here, the API keys, and then you create this API key using the create API key button. Okay, perfect. All right, so I'm going to ask you for another thumbs up. My application is working correctly. Okay, so give me a thumbs up or thumbs down on that. So that means we give you the right key. So at least from our side, we've given the right OpenAI key. Perfect. Awesome. For the people who are waiting for me to proceed, just give me a moment. We're just getting there. All right. So I'm gonna go back to my application and I'm gonna walk you through very quickly what this application is. Now, all right. So my application has client, which is my web app. It, you know, It is a simple TypeScript application which has a bunch of API behind it, and that's what basically we call to to invoke this agent behind the scene. So this app has you know uh, this, there is a send message, which happens when you click the send button. When you do that, it actually goes into this method, which is send, which calls our the agentic loop, which is in our agent support agent.ts file, and that's where we go from. So that you can see it actually launches a chat endpoint, and that's which is backed by our agent, and then it runs this method called run support conversation, which receives the chat request, it receives, and then it actually fetches the context, which is what is the context? Context is basically just saying what does dad use for a phone, right? So dad is using an iPhone 15, and this is the device summary and whatnot. And that context is then used by the agent to 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 complete the message. And this is basically the OpenAI prompts here, or OpenAI API calls here that actually sends the call, gets the response. So you can see OpenAI chat responses here. This is where we get the response from OpenAI, and if the OpenAI say, or the GPT model says that I need to call a tool, we call a tool, and these tools are either get me the support library information from there, or other. There are two tools here, and so the tools are defined in the tools.ts file. So you can see there are two tools in the execute tool function, which is get support context and search library. So if OpenAI model thinks that to answer this question in this context, if I need search help library or get support context, I'm going to call these methods. So this support context, if it is seeking support context, it actually, retrieves the same information. So that's basically how the application is designed. And how do I make this application connect to Langfuse? Now, that is what we are going to do, which is our first lab. All right, so I'm going to this folder, and then actually I'm going to go to learner, base app, which we got up and running. So I'm gonna skip that. I'm gonna just go to the tracing, and then I'll say, so now after your application is up and running, you go to git checkout tracing. So I'm gonna go to my terminal window, go this project, go back again, and then run this web environment. So now my app is at the tracing checkpoint. Okay, so we are on the tracing checkpoint. And now we are going to start adding Langfuse SDK in there. So first, we're going to capture we're going to initialize the Node SDK for Langfuse. How do we do that? We take this piece of code, 3 line of code, go to our code, first of code in the index.ts and paste it at the top. This initializes our Langfuse node library. And this is where basically we're going to work from. So now this starts the library, which means now our Langfuse is loaded in Langfuse SDK is loaded in the memory, and it is loaded the env file. And from env file, it knows where env file, it knows where is the Langfuse base URL, which it needs to connect to, and the permission are from this key, secret key and public key. Right. So now let me just go back to here where we made the change in the index. So we initialize this code. Now, what is the second step that we are told? You can skip this part, but if you are interested to use this part, then you replace this line that you pasted with the whole code here. So instead of doing this line, you're going to copy this guy. So I'm going to do that in front of you. So if you did that, delete this line, and then paste this here. And this shutdown method is right at the end. You have to replace the shutdown button. So don't worry about doing that. If you don't need to, just first 3 lines is good enough to begin with. Now, once we have done that, I'm going to go support agent. So the people who are doing for themselves, please carry on at your own pace. I am going to be describing to the people who are following me, right? So I'll probably be going a little slow than you would. Now we go back to support agent.ts, and then we import this library. This is where the backend agent logic is, right? So what we initially did, index.ts, is our server. When it loads that library, right? Now what we are doing is we're trying to add we're trying to add the SDK near the agent, and we're capturing the agent's calls. How do we do that? There is we will take this call. We already have this call in the code. This is where OpenAI is being called. So this is where OpenAI, this is what initializes the OpenAI SDK, right? So which allows us to call OpenAI model. Now what we will do, we will wrap this in observe OpenAI call from Langfuse SDK. This is what we imported. So observe OpenAI SDK is going to wrap this. Why we need to wrap this? So whenever OpenAI SDK is going to call the model, Langfuse is going to send, Langfuse SDK is going to capture that call and send that data into Langfuse, and you will start seeing the traces. So that will enable the traces to capture. Okay, so that's that. All right, sorry. And then we will just now do a question here. So now I'm going to ask a question, and then the trace should show up in my application. That's what we did, and we're gonna wait for a couple minutes for it to show up. Let's wait. That's this question again. How do I send this? Let's see. All right, so there you go. Now, what happened there? The Langfuse SDK was initialized. When the OpenAI SDK was initialized, we wrapped that into Langfuse SDK. So then Langfuse SDK is now monitoring the OpenAI SDK. So whenever the LLM is called, I am going to capture this and send this data into Langfuse. Now, this is async. So that means we're not actually slowing the inference. Remember, Langfuse is not in the middle of the inference call. It's just monitoring. As soon as the call goes to OpenAI, it actually captures that call, finds out how many tokens are used, and send that to Langfuse. So you can see here, there is a prompt for 93 tokens, and then there was a completion or output, which 131 output characters, right? So, and this is what the system prompt was, and this is the output. So let's go back to our code and see what happened there. This is the system prompt we're seeing, which is what captured here, right? Because that's what OpenAI is being sent in this code here. Okay. This code here, OpenAI system prompt is getting called. And then we're seeing the output, which looks like, sure, on your phone, go to the settings, blah, blah, blah. And that's exactly what we saw. On your phone, open the setting. So that's the first trace. And then you can see the second question that I asked. What about the second question that I asked, which was, how do I send SMS? And that's the system prompt, and you will see the output. Now you can see it is not looking good. It's just single disconnected output in the trace here. So what we're going to do is we're going to package that into a single call so you can actually see it really well. So now I'm going to pause here and ask a question. I see my trace, my agent trace in Langfuse. So give me a thumbs up so I know few of you have made the progress. Perfect. Awesome. Really nice. Awesome. All right, so now I am going to do the next part, which is packaging everything into a proper sort of like agents, steps, which is saying nested traces. So I'll go to the agent support.ts, agent support dot support agent.ts, right? And then I'll add another function here, which is observe, right? And this function is going to help us capture the nested traces. And now we're doing one more thing. We are exporting this method, which is making this method available to our other parts of the code. We are going to not export this just yet. We'll just find this method and remove the export from here. So now it's not exported, it's not shown to the other part of the application, but we will actually do is we are going to export it in a different way. So after the method, I'm going to paste this method, which exports this particular constant value. Let's see, without that done. Okay, so I'm going to paste this down. Okay, right. So yeah, so paste that the line of code from here to there. A slight change in there. So find this line and replace it with this line. When you do that, this is what it's going to look like. Okay. And then we export this method in our own way. Now, when we capture the trace, it is going to be called chat turn, a dead IT support chat turn, and it will be captured as an agent type of trace. So let's do that now. Let me just go here and say, refresh this guy. I don't need to refresh. I'll refresh it for capturing, getting these questions. And so now I said, how do I take photo? And then there is an answer. And I'll wait for this trace to appear. Why take a few seconds? Because remember, we are not sending everything right away. We're taking some time to collect a lot of traces, a few traces within a few seconds window, and then we are bulk loading into Langfuse. That makes Langfuse run really fast as it does. So if I refresh this now, looks like it is about to come. There you go. So after a few seconds, I can see my dat IT support chat turn with all the three OpenAI call wrapped into the same thing. And what this allows me to do is see the whole thing as a graph. So now I am actually seeing how my agent works. But my agent has a few more things than just the chat call, which is the tool calls. And so I'm not able to I'm not seeing that. So we'll do that in a moment. But you can see it went first to the OpenAI. OpenAI said, I need the get support context. So it called that. And then it says, I need the search help library. So it called that. And then it gave you the response. So there was a 3 calls to OpenAI chat, and each asked the harness, which is our agent, to do certain things. And at the end, when it says, I don't need any tool, it had the response ready, which was what we see in the assistant. All right. So who sees the graph in there? Who is able to see the graph in the trace window? Awesome. Now I will continue on. Sorry, there will be no breaks because we have so much to cover and I've got so much to show you. So we'll just, hang on with me for another hour and we will make it super rich, this particular, trace window. Now, all right. So now that we have that, we can potentially, as I said, we are missing the tool calls. So we go to the tools.ts and replace this with the code here. So tool definition gets untouched. So I'll show you how you do that. Tools.ts has this execute call. We're going to replace that. Before that, there's a tool definition. That doesn't need to change. To change this bit, whole thing, right at the end, from the export, delete that, and bring this new guy in. What you do, this is what the code looks like, the tool definition, and there's an observe added here. You can actually take that observe and put it in the top, for the better readability of the code. And then everything else is there. Now, what is it doing? It's not only wrapping the LLM calls, it is now wrapping the tool calls. So we are observing the tool calls. So whenever this function will be called in Python, our SDK will know it's called and it will send that. And because it knows what is the sequence from the timestamps, it can sequence things really well as well. And then there will be trace context as well that it actually uses. So you can see now we are calling the same functions, but these functions have been wrapped into an observe method, which actually starts observing that. Wherever you put the observe, it starts monitoring that. And whenever those functions are called, it sends that data back into Langfuse. So, all right. So with that little bit of change in there, I am going to go back to my dead IT support agent, refresh this guy and say, how do I reconnect to my iPhone to my Wi-Fi? And there will be an answer. Again, give it a couple minutes and see those traces will pop up. And now when those traces will pop up, you will see tool calls, which is what we asked the code to do. When we did that, we said, when this method gets called, attach, it as a type tool, and the name of the observation will be get support context. And this tool, which searches the library, is also a tool, and it is called search help library. So let's go back, and there you go. Now our agent is looking much richer. So you can see I have that ID support agent call, which calls OpenAI. OpenAI says, I actually need to get the context. So it will call the context. So there you go. You can actually see the context being called, which is the call here. And then second time, when it goes there, it says, I need the search help library to be called. And that's what it called. The search help library returned items, which is information about how iPhone is connected to Wi-Fi. That's our knowledge repository. This tool, the first one, gets more context, gives us the information about what dad is using. The dad is, dad is using iPhone 15. And that search help library gives us the answers. And that's how the whole agent works. Awesome. All right, so I'm gonna ask again, who was able to see the tool calls in the graph? All right, so a bunch of people. So now we are making it richer and richer, right? So now, what do we do with this thing? We have got that. We can potentially start looking for things that are interesting to us. Remember I said we find the things that we feel are interesting or might not have covered in our prompt and the agent logic. And when we find them, we have to improve this thing. So first, let's find these things, right? What could be of interest to us? Now, there's a bonus section here that says you can actually capture these OpenAI call under this propagate attribute. This essentially adds the user ID and the session ID to my chat calls, which means all my different chat conversation with the agent and the dad, if they are part of a single session, they will become they will all have the same session ID, and we will be able to use the session window for that. Now, you could actually capture that as this, and I'm going to do that very quickly. So I'm going to show you how it actually is done. And I normally make a mess of it. So what I'm going to do is so what we need to do is I go to support agent, and wherever I am calling the OpenAI chat completion, that thing, I have to wrap that. But in order for me to avoid that messing up this code here, so I'm gonna place somewhere uh, here. So what I'll do, instead of doing that, I'm gonna go back to my code repo and say git checkout slash check. I'm going to do that. Close this window, don't save, and then open the support again. And there you go. So propagate agent is added here, which actually captures the observe OpenAI call and wraps that into this thing and always sends the session ID and the user ID. We create the user ID as the context ID with the workshop name and then that. Now, what does that do? It actually, when we go to the application now, refresh this application. This is a new session. I ask the question. It will show us the trace in the same exact way. There will be not a lot of difference in the trace, but we will see something else. I'm going to ask a couple of questions. How do I find directions to my grocery store? So it's going to potentially tell me use the map application and do this thing. Let's see. Yep. Open the map apps and search the map box and whatnot, right? So it's doing that. But what did we just do? What the effect of that, I'll show you in a second. So now, the first question that I asked, how do I turn on the iPhone? So this was basically there. You can see here, now we have a session and a user ID, okay? That is important because if we were to have a multi-turn conversation with an agent, you need to capture all those turns within a session so you can actually get a single view and see how the interaction unfolded. And you can do evals on multi-turn conversations with that as well, technically. So if I go to session now, there is a session, and looks like there are two questions here. So first one was, how do I turn on the Bluetooth in my iPhone? And then the second one, hopefully I can see that. How do I find directions to my grocery store? So there you go. You have one view for both the, for both the observations within that session, right? And that's basically the session tracking. And now we have the user ID. Now we can also see all the traces of that user. Before we did not have the user ID. Now we can have the user ID. With that, what does it do? Is you can even see the cost per user. So if I go to Langfuse dashboard and go to the cost dashboard, it is going to start showing me the cost for the user. So it actually sees there was not, so most of our calls were without the user ID. And now the last call was with the user ID. So the workshop that user is now being tracked. So that means you can track how every single user is costing you in the agent your dollars, and who is the most active user and whatnot. So this is potentially can be done. Is this support for backend where apps are built using Python? Python or TypeScript, you can actually just do that. These are two SDKs that we provide out of the box. All right, so that finishes our tracing lab. So I'm going to move to the next one, which is the prompt management lab. I'm trying to go a bit faster now. Now you got the full idea. So I'm going to check out this guy. Okay, go to my terminal. In the app, check this out. We're here back again, and we'll start the app. Now, it didn't do anything. It just cleaned up and it just gave our code in the right shape as it is expecting at the end of tracing. Technically, there isn't any change in there. I'd say make sure your env has these two labels because we're going to create a prompt and we're going to label it with production. Now, what is prompt? Why are we creating prompts here? Because our code right now has hard-coded prompts. If I go here, this is my system prompt, which is hard-coded. I don't want it hard-coded. I want to take this guy out from here, okay, and create a prompt in Langfuse, and I want my Langfuse to be sending me this prompt, or SDK to pull this prompt. So I'm going to call it dead ID support agent, paste the prompt here, okay, and then I set this to production label. Now, prompts could have variables as well. In here, we don't have variables, so we are going to just create this prompt and save it. So let me just make sure that I'm not doing anything wrong. So yeah, name this dead ID support agent, paste the body of the system prompt, which I just did, and label it production. So whoever is following, create a new prompt in the prompt window, name it dead ID support agent, paste the code from here, exactly from all the way here, and paste it here, and then create the prompt. Now that creates the prompt, which is ready to be pulled from SDK, but our code is hard-coded with system prompt, so we'll change the code to pull that. So that means we're going to go back to our application. In the agent support agent, we're going to add Langfuse client, which allows us to initialize the client side of client SDK, SDK client, which will have methods to do like pulling the prompts, pulling the data sets and whatnot. So now we will do that by adding a method called getPrompt in the same file. We're gonna add a method called getPrompt, okay? And then which is copied from there. So follow this instruction. Number 3, prompt management. and then use it in the run support. So now we have to use this thing in the run support, fetch and call back. So I'm gonna copy this guy, right? And then go back here. It's saying go to run support conversation. So we will go to run support conversation. And here I'm going to paste the prompt. So this is where the prompts are going to be fetched. And then in the observe OpenAI call, we have to replace this with this particular bit. So I'm going to go to my this call, which is line 75. Replace that with this call. What it's doing in this example, all it's doing is sending a prompt explicitly here in the Langfuse, Langfuse as a Langfuse prompt. And that's basically that. And all you do is you just rerun the application. Don't really need to do that, but you can just do that. Now, when I am going to ask the question to that agent, it may be going fast for a few people, but it's hard to catch up. You guys will have the access to the recording if I understand correctly. Chris, is that correct?
Yes.
So perfect. So now I'm hoping that the system prompt is now pulled from Langfuse, and we will see in that our trace. So let me just go back to the tracing and see, what did I ask? I asked, how do I take photos on that side, right? So let's see if this is the question. How do I take photos on WhatsApp? Now, what is important here is we should see the prompt. You go to OpenAI chat, this, if you click this guy, you see that? Now it's saying prompt is this one. So if I click this thing, it will take me to the prompt. And if I go to the metrics, it will show me how many methods, how many times this prompt is used. So it's used 3 times. Remember, chat is called 3 times, one for getting the context, one for searching the library, and then one for answering the question. So every single call is calling ChatGPT, or not ChatGPT, GPT model 3 times, and that GPT model calls are now being used from this prompt, or now being sort of created from or generated from this prompt. So that's how we get the prompt in. And if I change the prompt, it will see the change. So if I go here, okay, I'm going off track. Okay, so don't do that in your particular environment yet. I'm going to say always ask, is there anything else I can do? That's it. Always ask at the end. Right. So now I have instructed to always ask at the end, is there anything else I can do? And I go label the prompt as production and create a new version. Now with that, I should be able to see my app being my agent do that. But remember, when I make a change, it takes 30 seconds to pull this data. So I'm gonna, so how do I, not how do I get around this 30-second wait? I just restarted my application. So now this is a complete brand new uh, you know, uh, SDK client, and it's going to pull that prompt as soon as it loads up. And when I now ask the question, it will pull the prompt, which will be the new prompt. And then I'm expecting at the end to say, is there anything I can do? Which it didn't. So let me just pause and see if that actually got the prompt right. So let's see. No, the latest one doesn't have any iteration yet, so it hasn't been pulled. Let's see. V1, it's not loaded yet. How do I put photo? What did I ask? How do I reconnect my iPhone to Wi-Fi? Let's see. So that's not probably my trace is not there yet. Yep, that's V2. So It did not. Let me see the first prompt, right? Oh, my prompt has not gotten there. Yeah, so my prompt is not loaded yet. Let's try again. Try refresh this one. That's the question. Ah, it's not working. Never mind. And then I have to see why it's like there's a second. Refresh this one and see if my prompt needs something better. But, wording and so end of the response of the final response leaves us every time response, blah blah blah, production label, so the new version. Leaves us, is there anything else I could do? Okay. Hopefully should work now. So yeah, again. Didn't work, we'll carry on. Okay. So never waste time. Should work. That's the undeterministic nature of LLM. It is not doing what I'm asking it to do. But let's see. Oh my God, it's not possible. It's not doing it. Never mind. Never mind. Okay, never mind. I'll carry on. So what does it say? So it says you can actually see the wrap and all of that. That's good. Let's get to the monitoring, which is the most interesting part. And hopefully along the way, we will see the message that I just asked it to do. All right. So for that, what we did here is we actually were able to pull the prompt from the prompt management screen, from prompt management feature, rather than hard coding the prompt in the code. So now I'll go to the code and pull this, say git, checkout, checkpoint, checkpoint, this guy, stash. So if you are struggling to do that, you can git stash that, and now we are back. Our code is on the right way, in the right shape. So if I go to the code, nothing is changed. Perfect. And now I will go back to my instructions. So the next lesson, which is the monitoring. I think we're tracking all right. I think we'll get to see the data sets. All right. So now I've done that. Now I'm going to publish, I've already got the publish prompt, so I don't need to. All right. So I am going to, so in this particular module, things get interesting. Now we're going to find the traces where user disagrees. So dad says, well, I don't see the menu. Or out of scope request, dad asked, file my Texas. Or dad is frustrated. It's, how do we know it's frustrated? Like all caps responses. So we're going to try to find interesting things that we can do with when we have this observability in place. All right. So how do we do that? For that, we are going to use a feature called evaluation or evals or evaluators, whatever you want to call it. And that's the evaluator feature here. So what evaluators do is you have two ways to run evals online. Remember I said there was online evals and offline evals? This is the online eval part. So in online eval, you can run a code evaluator, which basically runs your code and scores your traces for something. You could add a code in here and it will run every single time a trace will come. We will call this code and the code needs to attach some score to this thing. And that's deterministic sort of, way of measuring things. So, for example, in our case, if everything in caps, this doesn't need an LLM to know. It's a user is frustrated. If everything is capped, we can check in the code instead of sending this trace to an LLM to know what, if the user is frustrated. We can get that from the code and score that this way. Or the other type of evals are LLM as a judge, which is we have a bunch of them already in here, and you can create your own. So you can create your own here as well. But before we do that, it is very important to set up a connection. How are we going to call the LLM from Langfuse, where Langfuse doesn't know which LLM to call or doesn't have the key? So you go to the settings, you go to LLM connections, you create the new connection. Say OpenAI, yes, my webinar feed connection. And then go back to your code. Remember, we gave you the env file, the OpenAI key. Copy that key back in here. That's it. That's the connection we need for us to be able to use the evaluators, which are online and using LLM as a judge. So this is a very critical feature. LLM as a judge is a very popular feature. People use it to attach score to online traces using another LLM. Okay, it doesn't have to be the same LLM. It could be another one, or it can be same as well. So because the prompt is what is where the evaluation logic is written. So now we have out of scope request here. It's already there. I'm going to set up the connection. So use that particular connection. So now it's saying, okay, where do you want me to run this out of scope request? Well, I need you to run out of scope in observation. Okay. For what type of observation? So let's see our instruction. What does it say? It says we need to create out of scope request. Okay. And then it needs to be observation type generation. So it doesn't need to run on all tool calls, right? Because we need to run these evals on the generation. So we run on generation. And then it says where the tool count is 0. Because remember, it doesn't need to be a tool count call. It needs to be a response. So when there's tool count is 0, it means the LLM is responding to a question, which is the final response that we get. So here we get tool count equals to 0. That means it is the final output. All right. And you can even sample it. You don't want to run it 100% on all the call because it could become expensive if you have a highly, sort of highly frequently called agent. Then you can actually go and say, sample it 20%. But I'm going to do it 100% because we want to see it working. Now, this prompt is exactly what is saved in Langfuse out of the box. It requires that you tell it where is the system prompt and where is the last user message, so it can actually see whether the user's message was out of scope, right? Remember, we are not capturing, we're not judging the response of the agent, we're judging the input. So we are going to find what is the user's message here. So how do we do that? I don't want to make any mistakes, so I'll go here. This is the JSON path that tells Langfuse where to look for the system prompt. So I'm going to go here, paste it here. So in the input, the first message content or the message 0 is the system prompt. And your last message, which is the user's message, is what we need. So that -1 gives you the last element in the message array. And that I need to be evaluated. So now if you do that, with some samples here, if you select those samples, you will be able to see how it looks like. So you can see this is the exact prompt that we had, and this is the message that we have from the user, right? So we need to actually see, we need to do that. All right. So now with that done, I'll execute that. Now, every single time I will run an out of scope question, it is going to mark that as true because it's a binary thing. It's a true or false. So how do I know it's true or false? you actually go back here in the evals and go to eval library and look at the out of scope. It is a Boolean one, right? So you can see this is the Boolean eval. Let me just make it easier to read. So that's the Boolean one, right? Now I'm going to go back to my evals and I'll create another one. So just to quickly complete this lab. So now I need to find the user disagreement. There is a user disagreement eval already in place. I'm going to set up an eval and it says user disagreement. Now, what is the exact generation we're looking for here? It needs to be observation type of agent. So it will be the top parent observation. So we're going to say type or name agent, sorry. So we need to be name, no, not name agent, type agent, sorry. Type is agent. So it needs to be the top agent type. Remember the agent calls? And it also needs to be data IT support check turn, our exact agent call that we are looking for. So the name is data IT support check turn, right? Out of all the observations. So this is exactly what we are going to be evaluating. And now what do we need to evaluate in here? It's saying, give me the conversation history and give me the last user message. All right, I'll give you the whole conversation history, which is all messages. I'm going to give you that. And I'm going to give you last user message, which is the -1 thing. That's it. And execute that, which means they're both active. Now, any trace that falls and filters into this criteria, it is going to be assessed by this. Now that's what it is. Now we will add a code evaluator. So we're going to add a code evaluator. How do we do that? Remember I told you that we can call an eval, which is run the code. So I did that. So I go, okay. So I'm going to go to evaluator screen, click the code evals. And here I need to add the Python code. I can name whatever I want, but I'll follow the guidance here. So I'm going to name it all caps signal. So remember, all caps can be figured out without needing an agent, without needing an LLM call. Where does this Python code run? We actually call AWS Lambda, and this Python code runs in the AWS Lambda sandbox. So your code cannot go out of the internet. It will receive the input from Langfuse, and it needs to assess the input and give us the score output. So that's it. So you can't actually go and do fancy things in that because it's a sandbox. All right. What is the code? So let's copy this code and paste it here. All right. And that's why it's safe, because this runs in a sandbox. So now we have this thing configured. So that Python code is already saved behind the scene, but it's now asking us, where do I need to run this thing? Again, where do we run evals? Which type of traces? So we need to figure that out. So for that, you will see it will be live observation and the type agent. And this is IT support chat turn. All right, so let me just go here. Name, IT support chat turn, and the type is agent, not the generation, the agent. All right, so that's what we need to do. And remember, it runs on observation. You will see runs on experiments, which we'll do a bit later. So now we have got code eval and 2 LLM as a judge configured. So when I'm going to ask the question now, these questions will be assessed with that. I don't need to refresh. Yeah, of course, I refresh to know my application is not running. All right, so I ran my application, of course, and then I go here and I ask the question, which is within the scope, right? So I am not, we will see with that particular request will not be labeled out of scope, will not be labeled user disagreement, will not be labeled as user frustrated because there's no cap in here. So everything looks fine. If I go to my evals, okay, evals will run. Remember, we will need to run them on all the observation of certain type, but they will not be attaching certain things that we expect, right? So let's see. Let's just wait for a couple minutes. See number one. Wait. Hopefully now. Number one. What time is it? 17, and that's close to 30. So, all right. So, oh, 29. There you go. So this is, you see now our trace has some funny things here, which is the user disagreement, user all cap, and also our generation is out of scope false because this was in scope request, user was not disagreeing and all of that. So this is created out of the code, right? This particular bit. You can actually see the score here. So two of them at the root level, at the agent level. So two of them ran there. Both are false because, of course, both is normal case. And one of them ran on the final generation output, right? And it says, was that out of scope request? Not really. It was in scope. Now let me disagree. Okay. Let me disagree with this thing. I say, I don't see menu. In fact, I will do two things. I don't see the menu. That is going crazy, right? So this is disagreement, and this is also frustration. I am going to see, okay, whatever. The response is fine. I'm not interested in that response. I'm interested in what happened behind the scene. Let us see that. So we'll wait. It should come 32, something that close to 32. All right. And that's a bit of a, wait that normally we have to do. Because remember, we collect a few traces before we send it across. So sometimes it takes a bit of time. But we can see, one is run. So let me just go back to traces and refresh again. Refresh another time. Refresh another time. Or just 30 seconds. There, you can see, like, if you do past 30 minutes, this is recently launched. You can see the top bar. This is what we call, I think, pulse. Here you can see what was the latency of the response. What is the cost? So if you have a cost spike, you will know there was a request that actually had a cost spike. And also you can see the count of the traces in there. Now I'll refresh. I was just trying to, buy some time. Yep. Now I have got that trace that I wanted. All right. So now 31. This is the one. I'm still waiting for a couple of other information to land. There you go. All right. Now, user disagreement, true. Yes, because user disagreed, right? And out of scope, it was false. Yes, of course, it was in scope request, but the user disagreement was true. But we haven't got our code eval data in yet. So I'm going to refresh again, give it a second, and give it another second. Yep, now it's all caps false. Hold on. What's the user input? What was the user input? Let me just go back here. Maybe see this thing. There's an exclamation mark. Is that the reason? Maybe it's not good. The code is not smart enough to figure out there's an exclamation mark. So it's saying not everything is caps. I will actually show this now. I am frustrated. Okay, and I will wait again. Oh my God, you have to wait. I think there is a setting that can actually reduce the wait time, but I'm not gonna go figure this out right now. But yeah, we will see that. Let me see what else we have in this. All right, so that's pretty much what it is. Uh, in fact, what I'm gonna do in the meantime, I am going to run some bunch of scores. So we already have actually created scenarios in the backend, and like a fake simulated scores that we will run. So actually, I can show you what the scoring or eval UI will look like. Okay, so I'm gonna do that in a second. I'm gonna let it refresh, get that new tracing. So if I kill my application, it should do that, hopefully. All right. So now I should see that. Okay. Yeah, 34 is in. 34 is in. So it will be evaluated in a second. While it does that, let me run this thing. What it's doing, it's adding a bunch of scores in the UI. So we can actually go to UI now and see a bunch of scores. So if I refresh this in the last 1 hour, you can see like, we will get in a second, hopefully in a second. Come on. Come on. Ah, let's go back to that trace. Now you can see all caps true. So this trace was all caps, frustrated, right? User is frustrated. Yes, it was frustrated because all caps without any exclamation mark. So now we are able to find out when the user was frustrated, when it was disagreement. Disagreement was false, which is kind of should have been, I don't know. The user is not disagreeing, it's just saying, I'm frustrated, which is fine. So let's go back to scores, and now we should have all the scores in. So now because we have the scores in, we will be able to see the analytics. In here, you select the score, disagreement versus whatever, all right? So now you can actually see the trend over time of different metrics, right? And this way you can have like confusion metrics on when disagreement happens, the user has a caps on or not. It was able to figure out that there was a case like that, one observation where the cap was on, but the user disagreement was kind of false. This was the case, the three observation. So yeah, you can actually see the confusion matrix, your trend over time, your distribution of the score over your data, which is what the scores do. Right. So we have got about 20 minutes. I am going to try to use the next 10 minutes and then I'll leave the last 10 minutes for conversation. Data set part. Okay. So from monitoring, we go to the data set. So with what we learned from monitoring, you can actually capture things online with the LLM help or with the code help, attach things to it, and then be able to search. But let me go and show you that. If I wanted to know wherever the user disagreed, I can actually now go here and say disagreement true, right? And all the traces where disagreement was true are now filtered. And because they are filtered, I can actually see that. And remember, there are some which are added as a trace name. So this was like, as I told you, like we faked the data. So there's a lot of disagreement here, which we never entered. But this is because we actually faked the data with just the run that I did. So now that means you can search. Once you search, you can do a lot of things. You can actually send it to annotation queue. You can say, well, I wanna send it to annotation queue, have it reviewed by a human in the loop. So I can create an annotation queue. This is not part of the workshop, but I'll just create it. What SME review of frustrated users. Generally it's much more meaningful. I have to configure the score. I'm going to say developer. This is a score that says developer fix required. I don't know. It's Boolean true and false. So my annotator is saying, yes, developer should fix this or not. Please fix the problem when you see true. I don't know. Okay. So now I'm going to go human annotation, create a queue and say, I'm going to call it, a frustrated user review. Okay. This queue has all frustrated marked traces. Please review and tell us if developer needs to fix this. Okay. And then we use the score config. Scores config is basically saying it's a custom configuration, Boolean true and false, but has a certain label. Okay. Who's going to be assigned? I'm not assigning it to anyone. I'm going to assign it to myself. So, all right. So that is the queue that is assigned to me. It doesn't have any item right now. I don't see anything in here, but I can find those traces where user disagreement is true, pick them all and add them to the queue. That means a person later, not me, someone else, logs in, goes here, can actually go through each individual item and tell me as a developer where do I do where do I if I need if I need to fix that. Uh, I did all that and it still doesn't work. This is ridiculous. Like, oh man, you know what? This is something the developer must fix. Okay. That mark completed. The next one, I don't see the menu. Well, I think we don't need to fix it. So we'll say false. Okay, carry on. So that's how you actually carry on. And this way, now in the traces, you can filter things that are marked to be fixed. So if I go here and I say, where developer fix required is true, what are the traces that require this thing? So you can see now developer can always come here. In fact, developer can have their own queue and you can see that, or they can come and search here. So this way you can actually find interesting traces and label it something, have the human review has annotation, and then the annotation can be used by developers to find the item that they should work on. But in fact, this could be all automated. Like agent should find the items that humans have reviewed and said, you need to fix it. So agent will use that. Remember, we have CLI and MCP. In fact, you can have self-improvement loop wherever human indicates that this needs to be fixed. We know the metric, the threshold needs to be certain things. So agent can make the changes in the prompt and validate against the data sets. And if the prompt actually fixes that, then we just carry on. All right, so I'm going to now go to the next part, which is data set, and I'm going to go a bit fast here. Now we're going to create the data set. What is data set? Basically, stash. Data set is a set of items with the input and the expected output, which we expect our agent to sort of replicate. So that way, these items will help me gauge my agent at the development time, whether it is of good quality or not. And when I say quality, it could be anything. Well, we should be handling the user, where we should be handling the out of scope request. We didn't see that out of scope request. We should be handling it well. We should be handling wherever user is frustrated in a reasonable manner, right? So all of those things can be gathered as this metrics that you need to, or the evals that you need to run. And across all the evals, the average score need to be on certain threshold for your team to be confident to put that agent in production, if I make any sense. So what I mean is the confidence is where we started from, the whole thing. People are not confident, they're not putting agents in production. How do we make ourselves confident? We capture all the cases that we think of that our agent should handle, and we should eval them. We should come up with the scores. We should aggregate these scores. And then when the score looks good, we are fairly confident. And when they put into production, we capture on online traces, we apply the same logic for scoring, and then we make sure that the score in the online setting is not dropping. If it's dropping, that's the drift from your online and offline evals, which means that drift needs to be fixed. And that drift can be captured if you have all the scores in Langfuse. All right, so I have done that. Now I'm going to create a data set in a second. There is a code that creates the data set. So where is that code? That's let me tell you. Our data set is called data ID support workshop data set. Okay. Our data set item look like this. So it's got the input, it's got the expected output, and the metadata. Right? Input is what is the input user is going to get, what is the agent output needs to be. That it doesn't have to be exactly the same output we expect. Remember, LLM will respond on different questions. So you need to give like some sort of a scoring or criteria or evaluating criteria, a rubric of some kind that actually just, LLM can use to understand whether it is close to the ideal answer, or you could have some deterministic things like expected keywords. So we can actually have a code checking that that whether the response has any of these expected keywords. And that's basically, we can score them. If all of them are there, then we can score them 100%. If 3 of them are there, then we have like 75%. This is up to us how we define our scoring. Metadata gives the context, which means if we are adding items that we think are easy, we should be able to see how our agents are doing on the difficult scenarios and easy scenarios. So that's basically why you want to add a metadata into this into your data sets. Right. And there are 2 fields like that we are going to use ideal answer and expected keywords for us to assess that. But for that, we need to create the data set. So let's create a data set. There is a script in there that actually does that for us. It's called dataset dot whatever. Right. So I'm going to go to the code and show you that. It's called C dataset or something like that. Yep. So this is what creates the data set, right? And yeah, so that's the code that creates that seeds the data sets. All right. I am going to go back. Now this code, when it's run, we will have a data set created in Langfuse. I'm about to reach my time window, but there you go. So this is the data set that created. All right, so I'm gonna make it a bit larger. So you can see I've got input in there, book my train tickets to Munich for tomorrow. Of course, it's out of scope. So what we expect, it is outside scope, right? And we should, agent should politely say that I cannot do that. It is outside my scope. And the category here is out of scope. So we expect the out of scope to happen, and difficulty is easy. Yeah. Book my train should not be handled by agents. It's an easy thing. So here we have some easy and medium scenarios that we can run our evals on. Now I will show you the code that will run actually that eval. So all we do is we created this data set, and that's about it. This is what we needed, and that finishes our module 6. And I'll go back to the terminal window and say git checkout checkpoint. And then I move to the next one, experiments, right? So now we are going to see what we can do with this data set. In your traditional application, unit tests are run by test harness. Experiment is like a test harness. It's like a construct that feeds your application logic dataset items one by one, so you can pass it through your agent logic and assess them and bring the output out. So there is a code in the repository, okay, which if I go back now to experiments, there is a code in the repository that actually does that. So there is a file called run dataset.ts. Okay, and that will actually run the experiments. What does it do? And actually, this is a method that is like a test harness. What it takes, its name. What is the experiment name? So we're going to name it. We will attach some metadata like model, what we are doing. If we need to concurrently run this thing or single-threaded run is fine. If the single-threaded run at a time is fine. This is the logic where we are calling the agent. Run support conversation agent is our agent loop, and that's what we call the item is fed into it. And that's the task that is run. It collects the response, and it actually evaluates things online. So it actually evaluates whether there is a keyword overlap between the keyword in the expected output dot expected keywords. Remember, the data set has expected output, the keywords. So it actually checks there is an overlap or not. And if it does, it actually scores that. And that's how we actually run the experiment. Now, how do we run the experiment? I'm going to go back to this here, and then just quickly run the code here. So which is data set run. I apologize if I'm going a bit fast. But when I do that, these experiments are run, these data sets are fed to this logic, it actually evaluates things, overlap of the keyword, and if it is in scope or out scope, it does that. But and you will see that. I skipped a couple of parts where yeah, I have to set up a correctness evaluator. I could do that too. For example, hmm, should I do it or not? Do we have time? I'm going to show you that very quickly. Evaluators can be created to run. So I have a correctness evaluator, but I don't want to run on observation. Remember, observation is the agent actually running in production live. I want to run experiments. And what type of experiments? I want to run on a data set called ID support workshop. On the experiments of this particular case, I want to run this thing. Again, eval has some expected input output. So we need to give it some variable. So I'm going to give it a variable very quickly. This guy, and leave it blank, and then ideal answer is this thing. So I'm going to go and give it this guy. Generation is output. So we will keep it as output. Generating is output, and expected output is that field. So I'm going to change this to expected output and this thing. So now my generation looks good. So this is the generation. This is the ground truth, which is basically the expected output, and that's it. Now this particular run, this particular eval will only run on the SDK. It will not run on observations, right? Because this is part of the score. So if I go back and run this, hopefully it finishes. Once it finishes, I will be able to rerun it again. But I want to show you one thing here, one last thing. If I go to data sets, I see the experiment which I ran, and then I can see what was the input and output and what was the score that it gave me. You are not seeing the score because the data set has not finished running, but you will be able to see the scores in a second. All right, so now I think it's getting there. Click this guy, experiment. Experiment is finished. You can see the scores. So that's how we actually get the scores. You can see the trends over time of this score as well. So if I actually want to see, how these evolve over time, we can actually do that as well. I'm going to go to the scores, analytics. I can see correctness and keyword. I can see the charts here, but then we can also see the evolution of this particular experiment over time. So if I run it again, there will be another number here, and there will be a line. So you can see if the line goes up or down. I'm going to pause here because that's a lot of information, I know, but I hope it was useful. If you have any questions, please feel free to ask these questions in the chat window, and I'm going to be able to answer these things. All right. Any questions that we haven't answered? Recording will be available to the people who've registered. So yeah, do look out on your email that, and just so you know, OpenAI key will be disabled right after this webinar.
Thanks, Ali. It's great. And just while the people are sort of there, quickly before we wrap up, I'd also like to quickly ask a quick 1 minute poll. I'm going to launch that now. If you guys can give us some feedback, that'll be great. Thank you.
So you should be seeing poll in your
On your screen, yeah.
screen. No, I am seeing as well. All right. Has everyone
Excellent.
seen?
Thank you, Lynn. Yeah.
Awesome. Awesome. All right. Any questions? Can we customize the evaluators for each case in the dataset? Technically, yes, you can customize. You can actually create your own evals. I probably should have shown you. Evals are out of the box, and you can create your own. So you can actually put your whole prompt yourself, or your TypeScript or your Python. You can give it to us. You can name it, and that becomes your custom eval. It can be numeric, Boolean, or categorical. And whenever you want to run it on observation or experiment, it's up to you, right? So yes, you can customize these evals. Any other question? If we have missed the question, please repeat your question here so I can see it and answer. While I do that, I'll show you because I run two eyes. You can see the line. Now that's what we want. We want to see the data set over the period of experiments need to not drop its metrics. What metrics? Mainly on the correctness. The correctness need to be good. And the keyword overlap is another one we have here. It needs to be good. So that way you can do that. You can actually select two experiments, compare that, and see every single input side by side. So you can actually see the traces as well in there. What is the score? Whether the score improved or not, and all of that. Will the token usage and cost incur from the evals we track? Yes. All the traces of the evals are also tracked. If I just clear all that, some of these are now coming from our SDK. So the ones which are from SDK, that experiments is in here. The ones that are from your LLM as a judge is over here. And because everything is captured, your cost is captured. So now, can I get like a thumbs up or thumbs down on, was this a useful webinar? Awesome. All right.
Thanks, Ali. It's been great. And before everyone goes, I know we're sort of just at time. I'm going to ask another question. If people sort of want any further information, just answer the next question on the poll, please. Again, another pop-up. Anything else you have, Ali? There's no more questions online. And yes, we will be sharing the recording after the event.
Awesome. So we have 2 more minutes. So if you have, I'll show you, can I file my text? I'm not going to stop demoing things to you. Like, remember things out of scope? This should be eval as out of scope. And I really hope it says, can I do something for you at the end? Is there anything else I can do? Yeah, so we got that too. All right, awesome. Now the last trace, we should get that, not the SDK, production one only. Or I can do that, and that will also be. Kill that, and that should send the data in a couple of seconds. And then, never mind, I'm just trying too hard to show you, like, that thing also, autoscope also works. All right, one last try. Come on. Um, Session. Chasing. Never mind. All right, so trust me, bro, it works. Anyway, So thank you so much for the time today. We are on time, and if you have any question, please reach out. Our team is available. You can add me on LinkedIn. You search Muhammad Ali Langfuse. You should be able to find me. And if you have any questions, feel free to ping me on LinkedIn as well. Awesome. Thank you,
Thank you very
everyone.
much. Thanks, Ali. Thanks a lot. Have a good
Bye.
afternoon.